Hello, everyone. It's Grace Leah Jiroge. Today, we are talking about discussion board 4, focusing on the factorial ANOVA. We do want to briefly discuss the differences and the similarity between the ANOVA and ANCOVA when we run it in SPSS and what we use that for. So the question that we ask ourselves is, does considering more than one independent variable at a time provide additional information? Because if it's going to provide more than that basic inferential statistics for each independent variable separately, we want to use the ANOVA or the ANCOVA. So the differences here are that with the ANOVA that we're focusing on today, this is what happens when we have small number of independent variables, usually 1 to 3, which is what we're going to see on that data file that we're pulling. And then each variable has the number of levels or categories. For example, we have the level of the father's education, whether it be high school, some college, or a bachelor's of science or more. Very small number of categories there. Whereas the ANCOVA is used to adjust for the covariate. We're going to use it to predict differences in one dependent variable when there's one or more discrete variables and one or more continuous variables. Then an ANCOVA would be more appropriate. The 3 assumptions of the ANOVA are that observations are independent. For example, one student's math scores are not systematically connected to or related to another student's math scores. The second one is that there's homogeneity of variances. And then the third assumption is that dependent variable, those are normally distributed for each group. Okay, so I ran the analysis for the univariate through SPSS already. When I'm done looking at the analysis of this first part, I'm actually going to run it through from the univariate all the way through the one-way ANOVA, so you can see that after we discuss those results. So for this table right here in the output, what we're looking at is the amount of people in the group. So here we have, for those math grades, less than an A or B, we've got 43 participants, mostly A and B, those are 30 participants there. And then down below is the breakdown of the fathers who are in each group of the Father's Education Revised. So the highest group we have is the fathers who are high school graduates or less. And then the lowest group we have is that some college there. And then we see that level 3 is our fathers with bachelor's of science or more college education. Now this one, our descriptive statistics, is important because these means right here is what SPSS is actually computing for us in the ANOVA. And then if you take a look right here under N, you can match this up to what we looked at previously with how many participants are in each group, and those should match up. Okay, here we have, based on the means, we see here that, okay, there is some statistical significance. Ooh, went too far there, to the results that were run just from the univariate. So something statistically significant is happening with these math achievement tests based on the father's educational level. And then here we see that again. There is a high statistically significance between the father's education level, how students are scoring on that math test. And again, we see down here, our just R squared, our numbers are really low. So we know that the test is statistically significant. And we get to explore that more when we're looking at the profile plots. This is the most simplified way, in my personal opinion, to look at the data to see, okay, where is this significance happening? According to this plot, there's not much of a change here if a student is scoring less than an A and B between what level of education their father has. But we see the significance if a student is mostly making A and Bs, then depending on their father's education level, their score significantly increases based on that level if they're already scoring high. But we still want to run this through the one-way ANOVA so that statistically we can see what is going on here. Okay, so we are about to do the SPSS walkthrough. And then once we are done with the SPS walkthrough, we will come back and I will read through the results. Okay, so I had run this earlier in a test pilot of this recording. So some of those pieces may already be in SPSS, bear with. Okay, so we're going to go to recent files. We are going to open up our data set. There we go. Okay. So when we open it up, we're going to go to, we're in data view right now. Usually we're in variable view. Mine is when I first begin the program. We'll do analyze, general linear model, and we'll do the univariate. That's what we're going to run first. Now, our dependent variable is the math achievement. We've got two fixed factors here. The first are those math grades, and I believe I brought the wrong one over. There we go, fix that. And then the next is the father's education revised. And so once we have those two in, we're going to click on plots. And then once we go to plots, we're going to take the father's education revised and put that on the horizontal axis. And the math grades, we're going to put that on separate lines. And the reason we do that is because it makes our data much easier to read. If you recall the plots that we just saw briefly, when we have those 6 different levels mapped out on separate lines, it makes it much easier to determine what's happening here. So we're going to go ahead and add that, make sure that it shows here below, and then go ahead and continue. Once you get back to continue, be sure to click options, make sure that descriptive statistics, estimates of effect size, and homogeneity tests are all checked. From there, you should be able to click continue. From there, you should be able to click OK. And SPSS is going to put there it is, our output. These are the tables that we just looked at briefly, the data that we just looked at that brought us, that showed us, there is statistical significance happening here between the father's education level because it's, less than that 0.05, it's even less than that 0.001, right? And then we're looking here, we see those plot points again. So what we need to do is we actually need to run the one-way ANOVA to see what is happening here on a deeper level. This, I want to point out again, is significant because these mean scores are what is actually being computed for that one-way ANOVA. Okay, these 6 cell means are the levels that you'll see as input. They're the levels here, 1, 2, 3, 1, 2, 3, that you're going to see when we put in those cell codes for the one-way ANOVA. Okay, all right. So I'm going to exit out of here. I'm not going to save that part because we are going to save the one-way ANOVA. Now, we're moving past that post hoc test because we're going to do the one-way. So we're going to start at transform, and we are going to compute variable. Okay. And when we get here, we can enter cell code. We're about to input those different levels. We're going to type 2, and then we're going to click on if. Okay. We want to make sure that we include if case satisfies condition. The spelling is really important here because SPSS speaks certain language. We're saying that math grade is at level 1 and the father's education revised is also at level 1. Then what we're telling SPSS is to use that highest level of math grades, highest level of father's education. We're going to click continue. We're going to click OK. It's going to ask us if we want to change the existing variable. Yes, we do. And then we're going to go through and we're going to do that for all of the levels that we need. So the next one is going to be 3. We're going to click on if again. And then we're going to go through and change these fairly quickly. And again, what we are doing is asking SPSS to go ahead and add in the variables of the different levels. What if the father has the highest, or the student has the highest level of education and the father has that middle level of education? And then on the next one, we are asking SPSS, what if the student has the lowest level and father has math grades, and then the father has the highest level of education? We're almost done here. 6 is, what if we've got level 1 on those math grades and yet father has the highest level of education? We'll continue that. Okay. Now at this point, what we can do is we will go to analyze. We will go to compare means. And then we will run that one-way ANOVA. Before we do that, check your data view. Make sure that that was all input correctly so that it's calculating the correct levels for us. Compare means. We'll go to that one-way ANOVA. Okay. And when that window comes out, we're going to take math achievement and we're going to add that to our dependent list. And then we will get our factors, which are those new cell codes that we just created. We're asking SPS to look at what if they have those 3 different levels of math grades and those 3 different levels of education for the fathers. We're going to do contrasts. So for our coefficients, our first one is going to be 1. We will add that. The next, we're going to -1. As you do this, make sure you add in each of those numbers. If you're like me, you have to do a double count. Make sure you got all those zeros in correctly. Okay. All right, so you should enter that 4th 0. Make sure it's there. Yep. All right. So what we're doing here is we're comparing the math achievement of scores of the students with those low, so less than A and B scores, versus the more than A and B scores. And this is if their father has the lowest level of education. So now we're going to click on next. And we're going to do this for the media. That medium score of some college. So you'll see our coefficients switch around slightly to account for that. And then next, our last set of coefficients, we're comparing the math achievement scores of students with those less than A and B, versus the more than A and B high grades if their father has the highest level of education. Got our 4 zeros there, yep. And if you're like me, you gotta talk yourself through it. There we go. I shall be there. You're gonna click on continue and then click on options. You wanna make sure that you have descriptives run and that there's the homogeneity of variance test done for our results. You're gonna click continue and okay. And there you have it. This should show you your one-way ANOVA, okay? So remember, these means were compared. This is what was computed for us to see if there was statistical significance. We see down here that our assumption of equal variances is violated, okay? So here we have a significant result, statistically significant result for that math achievement test, okay, according to the Levine statistic. And then we see here the overall F is statistically significant. It's really low. It's less than that 0.05, and that 0.001, we know that we're getting to statistical significance there. This contrast of coefficients lets us know if we added in our cell codes correctly. So if our data comes out, it's unclear, something happened, we're not sure where we went wrong, just take a look at your contrast coefficients, make sure that those levels were input properly, and it's a really quick fix to go back and get that done. Okay, and then this is our most important table down at the bottom. It shows us those different levels and then where we have the statistical significance here. So the interesting part about this is that if we look at the table, we see it's not all of those groupings that are statistically significant. For example, we have a really high 0.717, 0.742 for that first grouping. So that's if a father has low education, the lowest education scale, and the student is scoring less than A and B, it seems that there's not much of a statistical significance about their math achievement test. However, where we do see that significance is if a father has a bachelor's of science or higher, and if the student is scoring high in their math grades as well. And so this table is showing us, drawn out with the statistics, what that plot was showing us. What we're going to do now is go to the results and we'll walk through those, okay? So a factorial ANOVA was conducted to determine if there were any differences in math achievement for learners based on math grades and their father's education level. So we see that there is a significant interaction between how students are scoring on that math achievement test and what their grades are right now. If they are less than A and B or more than A and B, and the level of father's education. Okay, so a simple effects revealed that of students whose father had higher education, those who had mostly A and B grades, their math achievement scores were much higher than students who had lower grades. So for whatever reason, the students who were scoring less than an A and B, regardless of whether their father had less than a high school education or whether they had a bachelor's of science or more, their grades, their math achievement test scores not affected at all. However, we see a significant change in a student who has already been scoring with that higher, that A and B, more than that, and their father's education level. So we see when the father has a bachelor's of science or more, if the student's already scoring high, we're going to see a statistically significant growth in that math achievement score. So now we can confirm, yes, there's a statistical significance between our students who have fathers with higher education levels who are already scoring higher in their math grades. They are going to score higher on that math achievement test. The last slide here is the reference from Leach. Thank you for watching.